Hello? You can hear me. Sorry about this. Sorry. Audio's a nightmare, even on a Mac. Right? Try and do this on a Linux machine. It's some sort of special nightmare. Okay, so I thought, because we're in a cinema, it's actually a good space to do some sound. So I thought I'd start with a demonstration of the kind of things that I do. And can we see this? Is this working? Fine. Right, so what I'm going to do is I'm going to do a performance. It's going to be like 5 minutes. So enjoy, sit in comfy seats. I'll show you what you can do with the software, and then I'll talk about how and why I'm doing it. Let's go. As you and the audience look, enjoying yourselves. Epic scenes. Right.
Space, afraid, hot, craze. This way, no, but the same. I know. I'm screaming out my name. Give me eyes, give me break. I just can't escape. Higher, better than a dream. Flying like a dragon that I've never seen. Better in space, afraid, hot, craze. This way, no, but the same. I just can't escape. Higher, better than a dream. Flying like a dragon that I've never seen. Better in space. Afraid, hot, craze. This way, no, but the same. I know. I'm screaming out my name. Give me eyes, give me break. I just can't escape. Higher, better than a balance, bass, a frame, hat.
There you are. So let's try and displays. Go to arrange and do mirroring. Hopefully now we can see what's going on. This is the software I was using. It's software called Sonic Pi, and it was designed to teach children how to code, right? And so the challenge I had wasn't really, can you build some software that could teach children how to code? Because that's not that hard, right? Turing-complete languages are pretty trivial to implement, and there's a whole plethora of really weird and esoteric ones, which are very simple, and can obviously do the full plethora of programming, not that you necessarily want to build Kafka in Brain, F-U-C-K, but you could, right? And so the question isn't about, can you teach computer science, can you build something that could actually do the full computer science curriculum? The question was, I found, how do you engage that next generation of programmers? How do you get them to care, right? Because you've got them in the lesson, right? You're all doing really well, because you're all sitting down very nicely. Thank you very much. You're very quiet, listening, maybe you're falling asleep. Hopefully the music sort of woke you up slightly. This is not a normal, typical classroom. And obviously the children are not necessarily all focused and sitting down and calm and comfortable and relaxed and listening and attentive and ready to suck up all the interesting, exciting words you're about to give them and all the knowledge you're about to... They don't care. They don't want to be in the classroom. They want to be outside playing with their mates, playing football or whatever, right? Chucking a ball around. They don't want to be in that classroom. And they certainly don't want to be doing this computer science. Who wants to do that? What value is that? No one can't. The GCSEs in the UK don't matter in computer science. A-levels really don't matter in computer science. This is a problem that culturally we need to fix. At university level, suddenly it becomes useful and interesting. It's one of the most popular courses in the entire of the universities. But at school level, for some reason, it's still seen as really not that interesting or valuable or worthwhile. So that's the cultural pretext. That's what you're dealing with. That's what the kids know. That's what their friends have told them. Their peers above them have said that computer science is not that exciting. It's whatever. You're just going to do some entering a... My son went to his first computer science lesson a few weeks ago. I said, mate, what did you do? He said, we'll learn how to log into the system. Like, that was a full lesson. You know, and another lesson he learned how to do an email. Which, useful skills, but like, why is the computer science lessons teaching the kids how to write an email? You know, like why isn't the English lessons teaching the kids how to write? So why aren't we doing it at a much earlier age than at 11? So this is the problem. So I was tasked with building a computer science software system for teaching computer science, and so it soon dawned on me that the real problem was how to get them engaged. And music turns out to be a fabulous tool, not the only tool, but a fabulous tool within which to go into a classroom and do something like that, right? And the kids are like, what? And obviously they go, okay, you're some weird guy from university context, you know, like, you got a PhD in computer science. Of course you can do crazy code, that's beyond my skill. So it wasn't even a, can you even do this? But it was important to think about what is the equivalent of Taylor Swift. Because the reason why a lot of kids learn guitars and to sing and to produce music is they've listened to their favorite artists. And those artists have inspired them to pick up the guitar. They don't pick up a guitar because it's a beautiful wooden object, right? The kind of people that pick up the guitar because it's a beautiful wooden object are you people, right? Because you've all found programming, I would probably guess, please if you're wrong, I'd love to talk to you, because you just found it interesting. Because you liked computers, and they were cool, and you could like write words, and it would do cool stuff. And you found that interest yourselves, by majority, I bet. And then it sucked you in, and you stayed in that, and you're like, yes, I'm going to keep on. That is not normal. It's not normal, no more than the people who make guitars aren't normal. Because there's definitely there'll be a conference somewhere in the world of guitar makers talking about all the different kinds of woods they could use, and the acoustic properties of different shapes, and the strings, and the tensions of the bridge, and all this. Like, you can go into huge amounts of technical detail about guitars, and there's definitely going to be an audience for that. But they're not the people playing on stage, typically. And they're not the people that are exciting that next generation of guitar players. It's not the guitar makers. So I think that we need to think about this in terms of computer science. What are the influential figures? Are they Bill Gates and Steve Jobs? Really? Really? Because I don't know, that doesn't excite me in the slightest. And also, is making money the main objective to learn computer science? I mean, it's very useful for business. All of you, I am sure, are employed by a business to make money for that business. Great. That's not a bad thing. But is it the only benefit, the only use of computer science? Is it also the thing we should be using to excite our children? Look, you could be one of these people. Right? I don't think that's going to be the case. I think that in the same way you don't learn sport to become a professional sports person. I mean, you could be, but most people do sports at school because it's a fun, engaging activity, good for the body, good for the mind, good to run out and release some energy. Then not all of them are going to be professional sports people, only a tiny percentage. But we still teach sports. So we need to teach computer science in schools. I don't think to generate the next group of professional programmers, although it certainly will help. I think society will benefit from programming, and so we need to find ways to engage them. So I think we need to find what the equivalent of Taylor Swift is. Because if Taylor Swift were to write her next track in code, can you imagine how many programmers there would be tomorrow? Can you imagine that? And it wouldn't all be white-bearded guys. Right? And that's a good thing. So I think we need to find out that. So I built the system. I've worked with it. I've used it as an instrument. I've developed it in a cyclic way where I've thought of new musical ideas and implemented them and kept going. I've been working on it for 10 years now. And I could talk at length about how it works, and I'm happy to go into more detail about it. But what I really want to talk about is this. So this blows my mind. This was released, a video released a month ago. So that's DJ Dave. She's based in New York. And she's using my software to make that music. She produced that music with my software. And she's not a professional programmer like you, but she is a professional programmer. And when she performs on stage, she live codes. She writes concurrent programs live. Multiple threads executing simultaneously. And she performs to fabulous audiences. Let me just find her Instagram feed. Instagram. I thought I had it. DJ Dave. Here she is. And here's one of her, you can see all the Cody stuff. It's super cool. And she recently performed in front of this crowd of people. Where is this picture? I've gone past it. Can you see a picture with lots of people? Here we go. Look at that. So those people in that audience, they're seeing a professional programmer, but not one working for business, not one working on Java, Kafka, event stream, whatever, right? Immutable data store, whatever it is. She's writing live code, which is making the music they're dancing to. And I think this is really important to consider Sarah, DJ Dave, as a programmer, as a professional programmer, because it's really important to me at least, and I hope to you as well, that we try our best to change the social perspective of programming. That it's not just a tool for business. It is a very good tool for business. But it's not just a tool for business. It's also a tool for amazing human expression. And I think it's that avenue, it's that direction, it's that pathway which allows us, I think, to engage that next generation of programmers and to get them excited and to get them to care. Because I think that's really a big problem. Because in the UK, we had the new computer science curriculum, and they asked the old white people with beards, what got you excited by programming when you were a kid? And they were like, ooh, sorting algorithms. Maybe that, you obviously all probably quite excited. You probably all have your favorite sorting algorithm. Or is it like, what is it? Haskell's quick sort implementation is pretty beautiful. So bubble sort. Time sort is my favorite. Right, if you sleep for the duration of each integer, right, and then it will automatically order itself, but obviously it'll take the amount of time for the longest element in the list. That's the fun one. But anyway, sorting algorithms are they're not cool unless you're like weird like us. And if we want to engage these people and show them that programming is something for them, I think this is a fabulous approach for doing exactly that. And so this is what I'm doing. So I've been working on for the last 10 years, and I'm focusing on and trying my best to continue. So how long have I got left, by the way? I've completely lost the plot. 20 minutes. I mean, so I'm very happy to take it in any direction. I mean, maybe it's worth talking about the implementation. So this is the system here. It's a text environment. It's free. You write the word play. It makes a beep. That's your first program. Make it louder. You can test the subwoofer system by making a lower note. Oh, yeah, nice. So, yeah. So in a school, this doesn't work. So they usually have really crappy speakers. So, get some good speakers as the number one priority. You can play samples. So you can play like Loop Amen. It's the famous drum break. Play it louder. You can play it at half speed. You can play it normal speed. You can play it fast. You can do fun things, like you can treat the Amen break like an array. So instead of using the rate, I can use the onset option, and I can work through each drum like a list. So I'm just indexing in. Fifth drum, please, because obviously we computer scientists count from 0. And so I can create let's just go with this. This is the standard demonstration I give. It's an interview question, so get ready. So I've got my drum in a loop, which is pretty cool. Maybe you want to actually pick a random one, which is quite fun. Yeah, I like that. Right, so let's just comment that out a second. Let's make another one, right? Let's make a loop, and let's play the bass drum. Right, this is a good one. Right, or maybe let's go for like sleep one. I've got it really fast. I've got it in drum and bass speed, right? So that's why it's behaving differently than what I expect. Cool. Right, so this is the kind of code that most kids write after a couple of hours. Right, you've taught them how to play a sample, you've taught them how to do a loop, and actually it's really cool. They write this code and they run it. So the way to learn Sonic Pi, when you all go home, you want to play this and work with it, is to write the code like this. Don't press the run button. try and imagine its sound in your head. And then when you press the run button, you'll probably be wrong, and then try and figure out why that's wrong. And if you keep repeating that process, you'll learn much faster. So imagine what that sounds like. We've got the drums, we've got the crazy amen break going at the same time. Press the run button, and So this is the interview question. Why can't I hear the drums at the same time as the bass, or the bass drum at the same time as the drums? Think about that for a moment, right? This is a classic interview question. So someone knows, good, right? The answer is, and this is a real situation that happened to me. So I was in a classroom. This girl, she put her hand up, and she didn't read exactly this code, but it was the same. She had two loops like this, one doing one thing, another doing the other thing. And she put her hand up and she said, I've obviously made a mistake. What have I done wrong? Why can't I hear them both at the same time? And I looked at the code and went, ooh, that's not going to work. And she's like, why? And I said, well, this is just a fundamental problem about computer science. And obviously, I didn't want to explain. But I went to the teachers and said, because at that time, we were at the very early days of Sonic Pi, we were developing features and then teaching the lesson, and then after the lesson, we would talk about what worked, what didn't, and then we'd talk about what we're going to teach next week. Then I would build a new version of Sonic Pi for the next lesson. So I was always in this system where I was building new features on a sort of weekly basis. So I said to the teacher, can we teach them threads? Because the reason why this isn't working, obviously, is because it's not concurrent. The program gets into the top it's a single threaded application. So we get to the top, we run the first loop, and what does a loop mean? It means, why can't I see this? Yeah, run forever. It loops forever on this top line. So we never, ever get to line 7, and that never works because it's single threaded. So what we really need is two programs running simultaneously. One program running the top loop and one program running the bottom loop. So I said to the teacher, can we teach them threads next week? And she said, that sounds wicked, yeah. Because this kid wants to learn the drums and the bass. And she said, yeah, cool. And then the teacher said to me, is it on the curriculum? So when I look at the curriculum, it's got conditionals, loops, data structures, algorithms, all that good stuff. Does it have concurrency on it? Of course it doesn't. Because concurrency is hard, right? It's not hard, it's really easy. Hard part of concurrency is managing state. That's if you've got a mutable state that's shared across the threads, then you're busted. But if you don't do that, it's not too hard. So got these two loops, and so I wanted to do threads, but the teacher said, no, we can't do it, it's not on the curriculum. So I went back to that girl, and I said, and I didn't say this, I really should have done, I'm terribly sorry. If you really want to do this, you're going to have to wait till you're 18. Because when you're 18 and you still want to do it, then you can go to university, and they'll teach you concurrency. And she obviously, I told them, sorry, you can't do that, the system doesn't support it. And she heard me essentially saying, this music system doesn't let me play the drums at the same time as the bass. What a piece of rubbish. And she immediately switched off, she looked out the window, she wasn't interested anymore, and I'd lost her. And it was a real tragedy, because it's like having a child in a classroom focused enough to listen to what you've asked them to do and to do it is remarkable, right? And so this child was doing that, but it was magical because she'd not only listened to what we'd asked her to do and she'd taken it in, she'd synthesized it, and she'd imagined playing two loops at the same time. We hadn't taught her two loops, we just taught her one loop. This is the loop structure. And she's like, oh, cool, I can do the loop for the drums. Why can't I do the loop for a bass, right? So in her head, it was completely obvious. She wrote the code, it didn't work as she imagined it to, put her hand up, I came over and crushed her dreams. And it was kind of like having a little beautiful seed popping out of the ground, exploring the earth and like looking around, seeing the sunshine. It's like, no, get away, you've got to wait till you're 18, sorry. And it was tragedy. So I was thinking about how I could fix this. So in this case, I invented a new kind of loop. It's called the live loop. This is what Sonic Pi performance code is pretty much made out of. Let's call this one foo. Let's call this one bar. And now playing at the same time. And this is one of many examples of the innovations in Sonic Pi, which weren't just to teach computer science, but actually primarily were there to engage the kids and to give them stuff they wanted musically. And there was always a confliction between the two, and that was a really frustrating thing to work with, especially in a context where the funding was really supposed to be about teaching computer science, but actually I knew that to be able to teach that I had to add the musical stuff, but obviously there was a tension going on there. So that was an interesting time to be in. But now I'm free for all that. I'm independent. I'm also just started a project with the University of Sheffield, which I would like to talk to you about now, actually, because Although, and I could spend hours talking about this, and so if you want to find me and grab me and talk to me about it, I'm very happy to. And I've just given you 2 demos, really, of what you can do with it. So I want to promise to you that to go from what I'm showing you here, this simple stuff, to the stuff that DJ Dave's doing, the stuff that I'm doing, is just a matter of practice. And every single piece of functionality can be and has been taught to a 10-year-old child. So that's concurrency. There's a Kafka-like event system in there, which is like a tuple time series tuple space event system that you can hook functions onto to then trigger when you press the MIDI events that can call some of my code to trigger some other things, to start a loop, to kill a thread. Like, you can do really interesting, sophisticated programming. But every one of those features is actually pretty simple to teach. It's the combination of them which gets interesting, just like Lego. Every one of the Lego bricks is interesting, but it's a combination of lots of Lego bricks. You can make some really sophisticated, amazing sculptures and pieces. So again, I want to promise you that DJ Dave she's doing things on her own bat. She learned it in a university course, and she's running with it like an absolute amazing person. You could do the same too. But there's still the problem is that it's about the whole goal for my project was about lowering the barrier to entry. How do I lower the barrier to entry for creative experiences with code? And one of those barriers is, are there pieces of software that are easy to install? And so Sonic Pi is a Mac app, it's a Windows app. You can just run the installer on Windows and it will install. It's all cryptographically signed, so schools should be happy with this, but they're still not. It's still a huge barrier to installation in schools. Just installing a piece of software, some schools really just don't want to do that. Other barriers are, of course, a cost. It's free, it's open source. How to learn, there's a full tutorial built in. Everything I'm showing you and everything else is written in this tutorial down at the bottom, which is already translated into multiple languages. So that barrier there is gone. Hardware is another barrier, so you don't need a fancy MacBook Pro. You can run this on a Raspberry Pi computer. It's installed by default on the Raspberry Pi, so just a €30 computer plugged into your TV. You can do this at home. So all those are things, but the installation one was still a big one. So we were working on a project where we can build a web version of Sonic Pi. Can we imagine it so it's just a web app, right? And so the first version of Sonic Pi was literally just a Ruby script, which had 2 functions. It had play and it had sleep. And with these 2 functions, I could teach sequential programming, I could teach functions, I could teach abstractions and integers and numbers, arguments to functions, syntax errors. The sequential programming was the critical one. That was the first lesson we taught, that programs in sequential languages start at the top and work their way down. And so this was I built this version of Sonic Pi in 2 weeks. It was like, what? Because I had 3 months for the whole project to build a system for teaching computer science, to find a teacher, to go into a school, to develop a curriculum, to teach a curriculum, to assess it. 3 months was the entire duration for this project. It was ridiculous. So I built the first version of Sonic Pi in 2 weeks, and I made the simplest thing. And so I've done the same thing now, but on the web. Sonic-pi.net, port 4002. It's still very experimental. Oh no, I need to go to edit. There we are. And so this is just like a very simple web page. It's got some markdown that's converted into text. We were thinking about like building like a Jupyter notebook-like thing, which allows you to intersperse code with some documentation. So this could be a description of what you're doing or how it works, or you could be composing something and you could annotate that composition with some information on what you're trying to do. This code here is a language called Lua, which is a really cool embeddable programming language, which is going to be executed on the Erlang Beam virtual machine that's running on my server right now. And so this should hopefully, yes, make some sounds. And that's using the web audio API, which actually is really cool. I was actually quite surprised. I was expecting it to be pretty noddy and basic and just be able to play a few beeps. It's got a full-blown synthesizer system implemented in it. It's amazing. So yeah, I'm already at the first point of building an implementation of Sonic Pi on the web, working with the University of Sheffield. But what was interesting about building Sonic Pi, the first app, the web, the standard Mac and Windows app, was learning that implementing musical functionality that was really important inside the process actually turned out to be critical. A really good example of this was randomisation. So in Sonic Pi, there is no randomisation. Everything is deterministic. And artists often, they laugh at me and say, that's rubbish. Yeah, what I want as an artist is every time I press the run button for it to have a different melody, a different music. And I'm like, no, you don't really want that, actually. What you really want is you want it to be the same every time. Like, no, I don't. So, well, if you use randomization to make a riff or a drum break or some musical construct that you like, then surely you want to be able to hold it and name it and reuse it and recapture it and perform with it. If it's truly random, that's trying to pick up water with your hands. Like, you can't do that. So, but if you have a deterministic system, you can make it non-deterministic quite trivially. You can set the random seed to the current time, for example. Will give you sufficient randomization to get. It's not going to be, you're not going to do your crypto generation with that, but you're going to be able to make new piece of music every time you press a run button, that approach. And so, actually, it turns out that what I want to do with this system isn't just to build a copy-paste of Sonic Pi. I want to take advantage of the web. And one of the things that you can do with the web is collaborative jamming. That's what I've imagined. Like, wouldn't it be cool if we could all open our web browsers right now and jam together? Right? And so I'm using this technology called Phoenix Live View. There's actually a talk right now, which is really annoying, which is on Phoenix Live View. Actually, it's good that actually 2/3 of the conference again talked about Phoenix Live View right now, because it's amazing technology. And this technology essentially is running on Erlang Beam. Every user, this is a web user here, will get a WebSocket connection to their browsers. And I want to just see if this will work for you. So I've got this this QR code. I want to see if you can go with your phones or your computers or whatever it is. Your computer's not going to work, is it? Your phones are going to work. You're going to have to turn the audio on your phones and turn the volume right up. But see if you can go to this website. Look at that. I've got 25 people, 29, 30, 31. It's working. Well, that's pretty cool. I've never tested this actually beyond 2 users. So this might totally not work. So now I've got you all on the system. I'm going to disable my audio on my system, and I'm going to play. Oh, maybe I already have it running on another browser somewhere. If I do have, oh my goodness, let's kill this. Yeah. Let's kill that. There we are. Oh yes, I'm playing the audience. How cool is this? Right, so this is the first implementation, right? It doesn't do anything more than the ability for, what it does is it runs the Lua code on the server, and the server generates events to be sent to all connected clients. I'm distorting all your phones. How brilliant. This is why you shouldn't have crappy speakers. If you had really massive subwoofers on your phones, it would all sound fabulous. Look at that. So the plan here, obviously, is to start with embedding the collaborative jamming as part of the experience from the start, and to see where we go. So this is. I'm quite excited this actually worked with 60 connections simultaneously. Can you imagine a whole school of this playing all the computers? Or yeah. So I need to think about what would be for the next conference talk I give. How could I improve on that? Because maybe I could get half the audience to do one thing and half the audience to do another thing and conduct in this kind of way. But using this amazing Phoenix Live View technology, which essentially gives this WebSocket connection from my server to each and every one of your phones, and then activates the hidden built-in synthesizers in your Chrome and Safari web browsers and triggers them, I think it's a really exciting and powerful potential for engaging that next generation of coders and imagining the kinds of systems that they could build, jamming with their friends together, and rather than just looking at TikTok like that, they could maybe be jamming together in the playground. Right? I think that'd be pretty fun to do. So that's what I want to demonstrate. That's where I'm at now. So I'm at day 1. I have something that's functioning. It's pretty cool. It works in a sort of collaborative environment. So this is the first time I've ever shown anyone this tool except for beyond outside the research at Sheffield University. So I'm quite excited to do that. And so I'm interested to see where this goes, and hopefully you'll join me on this journey. But simultaneously, I want you to just, anytime you can, to talk about and share the joy of DJ Dave. I think that celebrate her existence, because she really is the Taylor Swift of coding. I think she really is helping to generate that next generation of programmers, and hopefully to put them in a frame of mind that coding is creative, it's expressive, it's not just a tool for building business apps, which are pretty cool. Let's just face it. Like, can you imagine a world, I'll finish on this point, Can you imagine a world where the only use of written language was for legal documents? Because that's the world we live in with programming. The predominant usage of programming is for business applications. Now, that's not a bad thing. Legal documents aren't necessarily a bad thing. But if it was only legal documents, that would be a bad thing. But the fact we have poems, we have plays, we have to-do lists, we have text messages to our friends, we have love letters, we have sonnets. These things, they add to the richness and the beauty and the vibrancy of life, of human life, that's way beyond an event data store. And so I think that we should be thinking about how to achieve that with coding, how using that to generate that next generation of programs, to get them excited too. And then we will be able to go to parties and talk about programming, because people will care. And that will be really cool, right? Thank you very much.